Okay, so what I see on one of your problems is that you've got a graph that looks something like this. And maybe this is closed, maybe it's open, I don't know. And this is closed. And down here, you got 1, 2, 3, 4, 5. So that's about -5, okay? And then up here, and you gave the range is -5, 0. Because of course it starts at -5 and it goes up to 0. So that wasn't a totally, and let's aim the camera so we can get the whole board. Okay, so what's the range? The range consists of all the y values that correspond to points on the graph. Okay, so I think you seem to do this. If you take all the points on the graph and project them over to the y-axis, you get all the y values from here all the way up to here. Okay, so the range is not -5, 0. Nope, but nice try. You were looking at y values, that's half the battle, but you got to get all the y values that correspond to points on the graph. And of course, when you do that written assignment, you want to be aware of that also. Okay, so that's a simple one to fix. Your range, I don't remember what this point was, but according to the scale I have here, if I just do this, maybe that's 4 up here. Okay, so in this case, the range would be -5, 4. Okay, so I'm going to stop the recording. And we'll see what the another example, just a small error that I see. You have an interval here. And you're asked for the domain. Okay, now that was actually, there were several, it was a piecewise function, but there's one interval like this where you're asked for the domain. And let's just put a scale on it. Let's say 1, 2, 3, 4, 5, 6, 7. And this looks like here, and this looks like here. So this looks like 1, 2, 3, 4, 5. Let's say that's -5.7 at this point. And here, this is just, we'll just say that's 2. Okay, -2. So the interval is -5.7, -0.2, not -0.2, -5.7. It's just a convention. On a test, I might not even penalize that because you knew what the interval was. But you do have to be able to communicate it. So if it did penalize, it'd just be a point or something. But my open math is going to require you to do it in the standard order. Okay, so that's all there is to that. I'm sure you understand that because, of course, you corrected it on your second try. Okay, another problem that people frequently miss. You've got a graph that looks something like this, and you ask if this is a function. Okay, put the x-axis anywhere, and it's not a function. Now, the easy answer to why it's not a function, it doesn't pass the vertical line test. The vertical line here would go through 3 different points. The vertical line can only go through 1 point. That's going to be very important in the last section of the chapter where you have to deal with inverse functions. And you'll see how that works. Now, really what it says, the reason it's not a function is if you choose this X value here and want to estimate your Y value, well, you'd have an estimate here. You'd have an estimate here. You'd have an estimate here. You got 3 Y values for the same X value. Which one is it? You can't choose. Okay? You need only one Y value. Let's put it this way. Function has only one output. For each input. If this is your input, you've got 3 outputs. It's not a function. Okay? So want to be clear on that. Okay, we need to be aware of the names of these functions. Now, your MyOpenMath gave you several functions in addition to the ones that I use, but it also omitted one that I use. And, you know, if the author was thinking the way I do, and it's probably a good thing he doesn't, but if he was, he would have used this function as well. Okay, so what we have is y equals x squared. Well, that's an easy one. That's a basic squaring function. Y equals x cubed, basic cubing function, or the toolkit cubing function, if you want to use the book's terminology, and it's a good terminology. Y equals 1 over x, which I call the basic reciprocal function. You're doing a reciprocal of x. And here you're doing a reciprocal square, the 1 over x squared function. There's the reciprocal square. And this is your basic exponential function. This one, it should be pretty obvious. That's an absolute value of x. It's the absolute value function. Y equals x, which I haven't included because it's a pretty uninteresting graph and somehow doesn't fit the scheme. Like, for example, for the functions that I use, these 5 here for the most basic functions, you need most of the x values, -2, -1, -1/2, 0, 1/2, 1, and 2, in order to get the shape of the curve. Okay? For an absolute value function, you'd only need 3 points. For the x function, you'd only need 2 because a straight line is defined by 2 points. So it doesn't fit the scheme of what I'm trying to get at, but it's an important function. So it's your basic linear function. And then y equals the square root of x is your basic square root function. And we haven't talked about it yet because we're going to very soon, probably tomorrow. We haven't talked about inverse functions. And this function is the inverse of this function. And you get the inverse function by taking the numbers in the table and switching them. Take this column with this column and switch columns. You have a table for your inverse function. That's how we do the square root. Also the inverse of this, which is going to be a logarithmic function. And we're going to see all that very soon. So you get used to thinking about these things. We won't do a whole lot with the logarithmic function till, probably late March, early April, but we'll do some. Okay, then you have y equals cube root of x, basic cube root function. So those are the names, and I think that includes all the names that you saw in the, and all the functions that you saw in the MyOpenMath assignment. It was basically these functions except for this one. Okay. I don't know if He's trying to just lead you to believe that all functions are power functions, or absolute value functions. He's not really trying to do that. He's got his own way of setting it up, and I'm sure he knows more mathematics than I do. I mean, I know some stuff, but imagine he probably knows more. Maybe not. You don't have to know that much to write a pre-calculus book, but you know. Okay, well, let's get that